Okay, so today we're going to look at the electrolysis of brine. Now, this is a more complicated scenario of electrolysis. Again, we're using electricity to split a compound, and the compound this time is salt. As you can see here, we've got sodium and chloride ions in the solution, and that is what brine is. It's in a water an aqueous solution, okay? And what you're going to get out of this lesson today is that you will know what happens at the anode, the positive terminal, and what happens at the cathode, the negative terminal. Okay, and there are three really useful products that we form from this process. So let's crack on. We've got a tank here that's full of salt water solution, okay, and that's what brine is. When we turn on our power supply, you should automatically think, well, the negative ions will go to the positive side, the positive ions will go to the negative side. And that's correct, but we've got more ions than we are showing here. We'll come to that in a moment though. The first product is quite straightforward because we've got chloride ions here. They will be attracted to the positive terminal here, and you'll produce chlorine gas. So we can write out a half equation here, and our half equation is 2Cl minus AQ turns to Cl2 gas. So we'll get bubbles coming off, as you can see, I've put them on here, plus 2E minus. So if we're losing electrons, you will remember from oil rig that OIL, oxidation is loss. So at the anode, we've got oxidation. Okay, and what's coming off is chlorine gas. So if you were going to do this, what you would see, what you might see is a pale yellow or yellowish greenish gas coming off. What you would smell is, you'd probably just think it smells like the swimming pool, and that would be your chlorine gas being produced. Okay, so that's so far so good. That's fairly straightforward. Just going to rub off these lines here so that it's a bit easier for us to make out what's going on next. So now you would probably think that at the other terminal you're going to get sodium being formed, but it's more complicated. As I've said, we've got water here, and when we have water, okay, we must remember that actually water dissociates. So we have automatically some H plus and some OH minus ions. Okay, and you can see that's a reversible reaction, and it's happening constantly. So it's at equilibrium, and it's only a tiny, tiny proportion of the water that is split. But there is some, and that's really important that there is some. So what actually happens there then, if we just add these ions, we've got H plus, and we've got OH minus, and we've got some H plus. I should really learn to draw my right first and then draw my circles afterwards. H plus, okay, and then we've got some OH minus here as well. Okay, so when we turn on the power supply, it's kind of like a race. So if you think about the sodium ions when compared to the hydrogen ions are tiny. They are literally just one proton. So they can zip through the water, they can zip through that solution really quickly, and they'll get to the cathode before those massive, slow sodium ions will. Okay, I say massive, they're not really massive, but comparatively they are. So actually what happens is we have these hydrogen ions, okay, getting to the negative terminal of the cathode. So we can write another symbol equation out here, half equation in fact I should say, 2H plus, and they gain 2 electrons, okay, and this is obviously aqueous, plus 2 electrons. We don't need a symbol for the electrons obviously because they're electrons, and that produces hydrogen gas. So again, we're going to get bubbles here as well. How do we tell whether we've got the hydrogen? Well, firstly, we're not going to smell the chlorine smell. Okay, And secondly, if we gather some of this, if we collect some of this hydrogen gas together and use a lit splint, then it will make that famous squeaky pop. Okay, so we can test that gas and check that we've got the hydrogen being given out. Okay, so we can collect hydrogen, we can collect chlorine gas, and they're two useful products. So here, if we've got 2 electrons being gained, we'll remember from RIG, R-I-G, reduction is gain. So we've got reduction going on here. Okay, and we've got hydrogen gas being produced. Okay, so we've got one final product, and it involves just the things that are left. Now, if we have a quick look through here, just to try and make it easier, I'll cross these things off. We've got hydrogen, so hydrogen's gone, chlorine's gone as well, and so that leaves us with sodium and hydroxide ions. So what you can see then is that when these things get together, we've got Na plus OH minus, okay, and so therefore we've got sodium hydroxide produced. Now, actually, this will remain in solution. It'll actually remain dissociated, but we can write it like this just to show that this is what's happening, and we can take this sodium hydroxide out and use it in a number of important processes. It's an important chemical, as is chlorine, as is hydrogen. So that's essentially the basics of the electrolysis of sodium hydroxide. If you've got any questions, then let me know. Otherwise, there's a sheet for you to complete as well. Okay, cheers and take care, guys.